In this situation, a moving cart with a mass of 4.5 kilograms hits a spring with a spring constant of 75 newtons per meter. The car is initially traveling at 3.4 meters per second and stops once the spring is compressed. What is the distance the spring is compressed? So this is a before and after situation. The picture here is helpful because we can visualize it, but it won't always be there. So recognize that we have a before and an after. So in this situation, the initial type of energy it's moving, so that's kinetic energy. And the final energy involves a spring. So the final energy type is elastic. And so because energy is conserved, the total energy it has initially will be equal to the total amount of energy it has in the final situation. So what we can say is that our initial energy, the kinetic, is equal to the final type of energy, elastic potential. And looking at our equation sheet, kinetic energy is 1/2 times the mass times velocity squared. And that is equal to the elastic potential energy, which is 1/2 times the spring constant times the displacement squared. Now it is just a matter of substituting in the numbers and solving for the unknown. So we could say 1/2 the mass, and it says the mass is 4.5 kilograms. Velocity squared. We do know the velocity. It is 3.4 meters per second. Squared is equal to 1/2 times k, the spring constant, 75 newtons per meter, times the displacement squared, or the distance squared. We don't know that. That's going to be our unknown. So now we just have to solve for this distance. So if we solve the left-hand side of the equation, we find out we get 26 joules, and 1/2 of 75 put parentheses around that. Now we divide both sides by 37.5 newtons meters. This side will cancel out, and this side becomes 0.69 meters squared. It's our distance squared. And so we take the square root of both sides, and our displacement is 0.83 meters.